Okay, this is one of those problems that math teachers like to give because it is not as simple as it would seem at first. In this, we're given a triangle, and we're asked to find the length of BD, which is this line from here to here. Now, I'm going to be like writing this down over and over, so I just replace BD with Y so that it'll make it easier for me to write the equations. Now, I have this Y, and I have the hypotenuse. But for the other side of the triangle, I have an x. So that gives me two variables that I have to work with. But fortunately, because of this line BD, I have two triangles to work with. Since I don't know what this size of this one is, I can call it 21 minus x, since I know that the length of this entire line is 21, and x takes up this much of it. So using Pythagorean's theorem, I can create an equation for this triangle here, ABD, where I say y squared is equal to 10 squared minus 21 minus x squared. And I'm going to rewrite this little part of it because I like to see the x first when I have it in a polynomial like this, even though rewriting it means the x is going to be negative here. And I've got a positive 21, which means when I multiply this, 21 squared is going to end up here. Negative x times negative x is x squared. And then I end up with a negative 42x for the middle term. Now remember, I still have to have this minus sign that I brought with me over here. Also, you'll notice I just automatically turn 10 squared into 100. Now, when I bring this minus sign and multiply it through, and then do the math on the 100 and what is going to become the negative 441, I can simplify this equation and get it down to negative x squared plus 42x minus 341. Now, I'll do a similar thing with this triangle, only this time it's a lot simpler because I'm using x and I'm not using a polynomial that involves x. So it just simply becomes 17 squared minus x squared, and that equals y squared. And then when I square 17, I get 289 minus x squared. Now, this is two different equations, but I can notice that since I set this one equal to y squared and this one equal to y squared, I can actually just go ahead and take the other side of the equation, this part right here, and this part, and set them equal to each other, since y squared is equal to y squared. And when I do that, I get a single equation with one variable, and that's x squared. Actually, it's a negative x squared, as you notice right here, negative x squared, negative x squared. Since they're on opposite sides of the equal sign, no matter what I do, bringing this one over here or that one over here, the x squareds are going to cancel out. So I'm going to end up with just a number on this side and then an x with a coefficient and a number on this side. So now I can actually do some simple algebra and figure out what x is. So now from here, I just rewrite the equation a little bit. 42x equals 341 plus 289. That equals 630. And now I can take it one step further and I can say, let's do our normal thing here, and divide both sides by 42. And now what we have is x equals 15. And at this point, I'm going to bring centimeters back in because we had centimeters in here all along. We just haven't been writing them down to save space. So x equals 15 centimeters. So this is really important because now we've got it down to, we know what this side is. This is 15 centimeters. We could go ahead and figure out this side if we cared, but we don't at this point because all we really want is this BD, which I'm representing as y. So now we can actually get rid of all of this other stuff that we use to get to x. Well, I'm not going to get rid of it. You're going to show it in your homework, but I'm going to get it off the screen so that it's out of the way so that we can have space to keep working. Okay, then, so we just keep going, and the hypotenuse is 17 centimeters. Now we know that x is 15 centimeters. And then we go back to the original Pythagorean theorem. Hypotenuse squared minus x squared equals y squared. Since we know x is 15, that becomes 225. 17 squared is 289. We subtract those, and we get y squared equals 64, which, if you know your square roots really well, it doesn't take very much for you to just automatically say, like, I can see that y equals 8 centimeters. And again, I brought the centimeters back in because we should have had them all along, but I was being lazy. And so that gives us, since y is this line BD, that gives us what BD is, 8 centimeters. There you go.